Okay, and you have one like this too. I think yours is a quadratic, so it won't be quite as complicated as this one. But what it says, here's the f of x, right? Find f prime of x, so go through that whole process, and then find where the tangent line is horizontal, right? Just like we did on that x squared plus 1. We said the slope was 0 right at the bottom of the parabola. Well, this function here, right, it's a cubic. You would expect that it might have two different terms in the graph. In fact, if you look at it on the calculator, that's what it looks like. Now, we saw this back in chapter 1, I think, when we were talking about where does the graph increase and decrease, and then we called these points right here relative extrema. This is a relative maximum, that's a relative minimum. And at that time, we said, we don't have a way to find those points other than put it in the calculator and go second calc, 3 for a relative minimum, 4 for a relative maximum. It would ask you the left bound, right bound, gap steps, right? But now we do have a way. We're going to have a formula for the slope of that graph at every point. And if we set that formula equal to 0 and solve for x, that will tell us where the tangent line has a slope of 0. So the first step is get the derivative. The second step will be set the derivative equal to 0 and solve. You're going to be doing this over and over again in calculus next year, if you go on to calculus next year. That's just a big part of what you do. Right, so let's see. We need to do the f of x plus h, which is x plus h to the third minus 3 times x plus h. Now, x plus h to the third is not one that you probably have right up there. But this is a binomial expansion. We did these in chapter 9. Remember, the first term would be all x, so it would be x to the third. The next term would be x squared and then h to the first with a coefficient in front that we have to get later. The next term would have x to the first and h squared and a coefficient which we'll get later. And the last term is h to the third. Did you remember where we got those coefficients? Yeah, what do we call a triangle? Pascal's triangle, right? So Pascal's triangle, you start with a 1, 1, 1. You keep adding up the numbers to the top, above it, to the left and right. 1, 2, 1, 1, 3, 3, 1. And you keep going until you've got as many coefficients as you need. In our case, we need 4. We have 4 terms, 4 coefficients. That's the line. 1, 3, 3, 1. 1, 3, 3, 1. So that's x plus h to the third. I mean, I know you don't see that one as much as x plus h squared, but that's one that you can get pretty comfortable with. 1, 3, 3, 1, I think we all know that one pretty good. So we've got to do this. Oh, just a second, I didn't need that. And then we've got to do minus 3x minus 3h. And now we've got to subtract the f of x, which is x to the third, minus 3x. Of course, the x to the third cancels. The negative 3x cancels. And now we've got f of x plus h minus f of x equals 3x squared h plus 3xh squared plus h to the third minus 3h. Okay, divide by h. And again, the h will cancel. H in the denominator will go into every term in the numerator. So now we are taking the limit as h approaches 0 of 3x squared plus 3xh plus h squared, thank you, minus 3. Okay, so by direct substitution, what do you get? Right, 3x squared minus 3, right? When I do direct substitution here and here, those terms go to 0. So 3x squared minus 3. Okay, that is f prime of x. Now, if we want to know where the tangent line has a slope of 0, then substitute f prime of x equals 0. It's the zeros of the derivative, right? It's not f prime of 0. You want to substitute f prime of x equals 0, just like you're finding the zeros of a function. So 0 equals 3x squared minus 3. Solve for x. 3x squared equals 3. X squared equals 1. X equals plus or minus 1. So let's look at our graph again. In the calculator, you know, where does it look? What are the x values where it looks like this thing has a turning point, right? There's one turning point, the x value, -1, right? There's another turning point, relative minimum, that looks like the x value, 1. So we solved for those points, right? We didn't need the calculator to do second calc. We can do this using a first derivative. So you have one problem like this, and it's quadratic. So how many points are you going to solve for if it's a quadratic? How many turning points does a parabola have? 1. Right? This is a cubic, so it had 2 turning points. The quadratic only has 1. So you can guess that when you get to this point, your equation is going to be linear. So that way you got one answer.